Hey guys, my name is Amir, and in this video, I want to talk about the security of the universal unique identifier and should you use it for sensitive features such as passwords, API keys, or session ID. Now, before we get into the security aspect of UUIDs, I want to talk about just the general structure of UUIDs. A UUID has a length of 128 bits. It contains 32 hexadecimal digits, which are separated into 5 different groups. The first group has 8 characters, the next 3 have 4 each, and then the last one has 12. And this results in a total of 32 alphanumeric characters and 4 hyphens. When we get into the security aspect of UUIDs, we want to focus on the different versions that are present within UUIDs. So a UUID has 5 different versions that are most commonly used. There are version 6 and version 7 as well, which are new. But for this video, we'll only focus on the major ones, which are version 1 through version 5. First, we'll talk about version 1, which is divided into 4 different sections. The first section spans over 15 characters and contains the timestamp of when the UUID was actually created. The number 1 here indicates the version of this UUID, and the version is always the 13th character in a UUID. The next set of characters are clock sequence, and after that we have the node ID, which is based on the MAC address of the system that generated this UUID. The issue with version 1 of a UUID is that the MAC address, the timestamp, and the clock sequence are all based on non-random values. And if you're able to get a hold of a version 1 UUID, you can decode it by using many online tools, and you'll be able to extract the node ID, which is the MAC address, the clock ID, and the clock sequence. And since you have now these values, you can predict future UUIDs that are generated by the same system. Now, based on this, most of the UUID version 1 is based on non-random values. And in a secret, what we're always trying to do is to make the secret as random as it can be so that it's hard to predict. Next, we have version 2 of a UUID. Version 2 is similar to version 1, where it has a clock sequence, timestamp, and a node ID or a MAC address. The only difference here is that version 2 is intended for distributed systems as opposed to modern web and mobile applications. Version 2 of UUIDs have similar issues as version 1, as the MAC address, timestamp, and clock sequence are based on non-random values. If you can get a hold of the UUID, you can extract the MAC address, the clock sequence, and the timestamp, and then you can predict future UUIDs that are generated. Version 3 and version 5 are similar because they use hashing techniques on 2 values that are name and namespace. Name is generally provided by you, and namespace is generally a UUID that is generated by other versions. And this is typically used for distributed systems where you would want to have different clients have the same identifier for a URL. Now, the issues with UUID version 3 and 5 is that you're supplying them with hard-coded values of name and namespace, and they will always produce the same hash. So if you can predict the same name and the namespace, you can generate the same UUID. This means that version 3 and version 5 will output a UUID that lacks randomness, meaning that it's not a good choice to be used as a secret. Now, the other issue here is with the hashing algorithms that are being used by version 3 and version 5. Version 3 uses MD5, version 5 uses SHA-1, and the issue with both of them is that they both produce collisions, meaning that their output for different inputs can be the same. So if you look at the characteristics of a secret needs to be random and unique. And if you're using version 3 and version 5 UUIDs, you won't achieve that. Hence, these 2 versions are not recommended. Next is version 4 of UUID, which is random in nature. Now, just by hearing that, you might think that, oh, this could be the right UUID version for your secret. Well, that's not the case because even this version has its limitations. First, let's talk about just the static values that are present within this UUID. The 2 static values here are the version and the variant, and they always stay the same. Moreover, UUIDs only consume alphabets from A to F, meaning that it ignores alphabets from G all the way to Z. What that means is a lower complexity in the string. The other issue here is the lack of special characters. The only special character that it uses are hyphens, but we cannot include them when we're calculating the randomness of a UUID because they are at fixed positions. Moreover, there are no uppercase alphabets, which further reduces complexity. Now, based on the limitations we have with the version 4 UUID, we have an entropy of 122 bits. However, if we compare this with a string of a similar length, with upper and lowercase alphabets, special characters, and numbers, we get an entropy of 236, which is almost double that of a UUID version 4. So whenever you're choosing a secret, the goal should be to prioritize randomness. Because if your secret will be more random, it will be harder for the attacker to predict it. Though the entropy of a UUID version 4 is still pretty high and will be very difficult for someone to guess it, UUIDs were never intended to be random, they were intended to be unique, and should not be used as secrets as it says in RFC 4122 section 6. So if you're using UUIDs as secrets, it's time to move on to something that favors randomness. When generating secrets, a good rule of thumb is to have a minimum length of 18 characters, and it should have upper and lowercase alphabets, special characters, numbers, and it should be generated using a secure random algorithm. I hope this information was helpful. If you like what you saw, like this video, and if you have any questions, drop them down in the comments, and I'll see you in the next video. Take care.